All right, we got another example where we're going to find our rational roots or our rational zeros. And if we can find one, then we will solve completely. So what I want to point out from this example is that it is an x cubed. If this was an x squared from the beginning, if it was a quadratic, then you wouldn't have to do all this. You could use quadratic formula, factor, solve using square roots, any of those options. You could solve by completing the square. That's another one we've worked on. But it's not a quadratic, so we can't do that. So what we're going to do is use our rational roots theorem. So we take factors of our constant, which is a -3, over factors of our leading term, which is a 2. All right, so plus or minus, so the fact that this is factors of a -3, we're just going to look at factors of 3, which are 1 and 3, over factors of 2, which is just a 1 and a 2. So here's how we write this out. It's plus or minus all these possible factors. First we take 1 and divide it by 1. Then we take 1 and divide it by 2. Now we're going to do the same thing with a 3. 3 divided by 1 is 3, and 3 divided by 2 is 3 over 2. So these are all of our possible rational roots. They may or may not work, but we test all of them with synthetic division. So we're going to start with the 1. We're going to write out our coefficients of our polynomial, 2, 1, 5, -3. Just be careful, if we were missing an exponent up here, like if we didn't have the x squared, we would have to represent it with a 0 down here. All right, then we do our synthetic division. We add down, and then we multiply. Add down, multiply. Add down, multiply, add down. Because we have a remainder, that did not work. So we move on to the next one. Well, the next one is a fraction, which we certainly could do, but I'm just going to go ahead and move on to the 3 just because it's going to be a little bit faster. So let's see if 3 is one of our roots. Here's our coefficients again, 2, 1, 5, -3. So we add down and we multiply. Add down, multiply. Add down, multiply. Oops. There we go. Add down, and we had a remainder, so that did not work. All right, well, I was hopeful. Now let's go ahead and try those fractions. We're going to try 1/2, which is the same thing as a 0.5. Here's the same coefficients we've been using. So we add down. 2 times 1/2 is 1. Add down. 2 times 1/2 is 1. 5 plus 1 is 6. When you multiply, 6 times 1/2 is 3. Add down. There we go. All right, so we do not have a remainder, which means that we found one of our roots. X equals 1/2. That's one of our answers. And here's our constant, here's our x, and here's our x squared. So now we can look at this quadratic, 2x squared plus 2x plus 6. All right, now here's a quick way you can check to see if this is factorable. If you multiply a times c, and you get 12, are there factors of 12 that add up to 2? And if you go through all your factor pairs, you're going to say it's not factorable. So that means we could complete the square, or we could use the quadratic formula. So I say let's just use the quadratic formula. Here's your a, b, and c. So x equals -b plus or minus the square root of b squared, which is 4. So b squared minus 4 times a times c, all over 2a. All right, so let's go ahead and simplify underneath our square root first. We have 4. -4 times 2 is -8. -8 times 6 is a -48. And then 4 minus 48 is a -44. So we have -2 plus or minus the square root of a -44 all over 4. All right, so I'm going to do two things at once here. Negative 2 plus or minus, well, no, I'm not. I times the square root of 44 all over 4. So you guys saw I brought an I because we were square rooting a negative number. Now that it's positive, we can break apart 44. 4 fits in 11 times. So that gives us negative 2 plus or minus 2i squared root of 11 all over 4. And then we look at our triangle of numbers to see if these can be reduced. You can divide them all by 2. So negative 1, 1, and 2. And we get x equals negative 1 plus or minus I root 11 all over 2. And do you guys see this plus or minus right here? That means there are two answers here. So negative 1 plus I root 11 over 2 and negative 1 minus I root of 11 over 2. But we can write it all together as 1. And then don't forget, we also found a rational root from the very beginning up here. Remember we said x is equal to 1/2, so that is our other answer right there. So also a 1/2.